This video explains electromagnetic waves in the Global Positioning System, or GPS. There are 27 satellites in orbit around Earth in well-defined paths. 24 of these satellites are currently in use, while 3 are in orbit as replacements if one of the 24 fails. Each satellite consistently outputs a circularly polarized EM wave at 3 to 10 GHz, which is the microwave range. Circular polarization is needed due to the magnetic field that surrounds Earth. If the wave were linearly polarized, the wave would be altered as it passed through this field. Circular polarization prevents this effect. Each satellite also provides specific time information about when the signal was generated to control facilities around the world. These control facilities then supply this time information to each GPS receiver. The receiver can then measure how much time it took the signal to be transmitted by the satellite and reach the receiver. This time delay is then multiplied by the speed of light, and it outputs the distance from each satellite. The control facilities, discussed earlier, also have correction processes in place to reduce inaccuracies. Each GPS receiver also needs to be in view of at least 4 satellites to properly pinpoint a location. Some of the pros and cons for GPS. Pros: it provides accurate location, travel time, and velocity. All this information can then be overlaid on a real-world map to reveal your actual location along with where you're heading and where you've been. Another application is the ability to track people, animals, or objects. By placing a GPS receiver on a target, that target can then be tracked remotely from any location on Earth using a GPS. Some of the cons is that the EM wave does not transmit through any material. For example, if you were underground, the EM wave would not be able to penetrate through the ground and provide location information, due to the fact that the ground can be conductive, causing the wave to attenuate, or that the velocity of the wave slows, therefore having a larger time delay and providing inaccurate information. Another issue is when you're in proximity to tall structures, the wave can be reflected off of tall buildings, for example in New York City, and provide a false location to the GPS receiver. These GPS signals also require consistent correction by control facilities on Earth. If these control facilities are not maintained and the correction processes aren't continually updated, then the whole GPS system would fail and GPS receivers would not properly give location information. So that's my presentation on EM waves and GPS, and these are my references where I got my information. Thank you.